Hello everyone. So in previous class we have studied about the EIGRP messages. Okay, so we have completed the query and the reply messages. Okay, so today we will discuss about the types of neighborship that we can see in the EIGRP. So today we will discuss about types of types of neighborship. So basically there are two types of neighborship we can see in the EIGRP. First one is dynamic neighborship. Okay, so this type of neighborship, whatever practical we have done till now, so they in all that we were performing the dynamic neighborship. Okay, so we were performing dynamic type of neighborship till now. Okay, so now we will see a new type of neighborship, which is the static neighborship. Okay, first we will understand what is static neighborship. Okay, then we will see the practical. Okay, then we will observe the packets. Okay, how this static neighborship performs or works. Okay, so basically this is our router 1 and this is our router 2. So they are two routers. Okay, and they are connected with each other. So what happens in the dynamic neighborship, that it will send the message in the form of multicast. Okay, if a hello is generated, then it will send in the form of multicast. But what happens in the static neighborship, that we will tell this router 1 statically, we will provide manual entry. Okay, and we will tell this router 1 that your neighbor is, suppose it has IP 12.12.1 and it has IP 12.2. So we will tell this router 1 that your neighbor is 12.2. Okay, and we will tell this router that your neighbor is 12.1. So what will happen here, the hello message will be a unicast. Okay, suppose R1 is sending the hello message, then it will send towards 12.2, because we have already defined the neighbor to R1. Okay, but suppose if we are performing statically neighborship here and dynamically neighborship here, then the neighborship will not form. Okay, we will see in the practical also. If we are performing dynamic neighborship here, then it will not form, because if router 1 is sending the hello message as a unicast, then it will expect that it will get the response, or it will get a hello message in the form of unicast, not in the form of the multicast. Okay, let us see this thing. Okay, after that we will discuss some other things. So just wait for a while. So let us open all these routers. Let's just wait for a while. Let our routers get hooked up. So they have come up. Let's open them. So now we will configure. Let us see the interface. It is E0/1 on both the routers. So we will go here in E0/0. We will add the IP 12.1.1.1 255.255.255.0. no shut, exit, router AIGRP. We will take AS number as 100. Okay, let us configure IP first here also, and let us capture this link E0/1. Okay, let us open this link. Now we will come back to, sorry, now we'll go to the E0/1 here in the IP address 12.1.1.2, 255.55.0, no shut, exit, router EIGRP, router EIGRP 100. Okay, so we haven't advertised network yet. So what I'm going to do here, okay, first I will make tell this router that your neighbor is 12.1.1.2. Okay, oh sorry, one more thing, that we have to provide the interface here also. Okay, we will provide both neighbor's address and the interface. So here what I'm going to do, okay, so it will not generate message here till now. Okay, but if we will see the routing protocol, do show IP protocol, as we can see here, protocol is enabled on both the routers. Okay, but we haven't advertised anything yet. So here do show IP protocol. So here we can see our EIGP protocol is right now it is running. So it has the router rate 12.1.1.1 and it has router rate 12.1.1.2. So now what I'm gonna do, I will advertise one network here, router EIGRP 100 and network 12.1.1.0, 0.0.255. So I have advertised this network. Mm, so it has started sending the, here we can see it has started sending the hello message in the form of unicast. Okay, basically here we can see it is sending towards 12.1.1.2, which is the IP address of router 2. So here those were the exact same fields that we have discussed in the previous lectures. Okay, it has some parameters like k values, k1 and k3 are active. Okay, which is by default recommended by the Cisco. But we can see here, although we haven't advertised on the router 2, now what we are going to do, we will go into the router EIGRP 100 and we will advertise here also. Network, it is 12.1.1.0 and 0.0.255. Okay, now we can see here that 12.1.1.2 also started sending the hello message, but it is sending the hello message in the form of multicast. Okay, here we can see that. Okay, let me show you. Okay, here we can see that in the internet protocol we can see the destination is in the it is the multicast IP address, which is 224.0.0.10. So basically this is how they are trying to form the neighborship. One is sending the unicast and one is sending in the multicast form. But we know that if router 1 is sending in the unicast form, then it will expect that it will receive another hello from the unicast way, not in the multicast way. If another router will send in the multicast, then it will not form the neighborship. Let me show you that they haven't formed the neighborship. Do show IP EIGRP neighborship. Okay, so as we can see here, router 1 hasn't formed any neighborship, and router 2, let me show you on the router 1 also, do show IP EIGRP. Okay, so they haven't formed the neighborship. Now what I'm gonna do, I will define statically neighbor to R2 also. Okay, so what was the command? We will go into the router EIGRP. Okay, now we will tell that neighbor and we will provide the IP, which is 12.1.1.1, and we will provide the interface also. Okay, so now what will happen, as we can see, when both the routers have started sending the hello message, look here, 12.1.1.2, which is our router 2, it has sent the hello message in the unicast form. So they have formed the neighborship in the unicast form. Okay, and they have actioned in the update message. Okay, and they have formed the neighborship. Let me show you here also, we got the message that neighborship has been formed, but Let me show you all here also. Do show IP EIGRP neighbor. Okay, so address is 12.1.1.1. This is uptime, all the timers we have already discussed. Do show IP EIGRP neighbor. Okay, here also we can see that. Now what I'm gonna do, I'm gonna create one loopback on R1. Let us say and L1. Okay, and I'm gonna advertise one network which is 12.1.1 dot not 112 1.1.1.1 255.255.255.255.0. Okay, let us do it no shut. Now I'm gonna advertise in router EIGRP 100. I'm gonna advertise this network 1.1.1.0 0.0.0.255 exit. So it should send one update message, and it then in that update message we should have the information of this. Okay, so here we have the internal route. It has the information of 1.1.1 network. Okay, so basically what I am showing you here, basically we can form neighborship in two methods. Either it should be dynamic or it should be static. Okay, so why do we need static neighborship? We'll discuss that in a while. First, we will clear that what is dynamic neighborship and what is static neighborship. Okay, now as we have cleared that what is dynamic neighborship, what is static neighborship, basically in the dynamic neighborship it forms or it generates the hello message in towards the multicast IP address, and in the static it will generate for the unicast way. Okay, so whatever the topology that we were going through, we call that as a full mesh topology. So what is full mesh topology? Basically we were performing the dynamic kind of neighborship. So what happens in the dynamic kind of neighborship? Suppose this is our router 1. Okay, this is our switch. Okay, and this is our routers. So what was happening here? Okay, this router 1 will send hello message in the form of multicast. Okay, it will also send in the form of multicast, it will also send in the form of multicast. So basically all routers were making two neighbors each. Okay, basically router 1 is making neighborship with the router 2 and router 3, and router 2 is making neighborship with the router 3 and router 1, and router 3 is making neighborship with the router 1 and router 2. Why they are making neighborship with all other routers? Because all the interface are the member of multicast, and they are sending the hello message multicast member of 224.0.0.10, and all the routers are sending the hello message in the form of multicast IP address. So they are exchanging their hello messages. Okay, and then they are making the neighborship. So that's why we can see that every other routers were making the two neighborship. Okay, so now what we are going to do, we want to make this topology not as a full mesh but as a hub and spoke topology. Okay, so we want to make topology as hub and spoke. So basically what happens in hub and spoke topology, let me write down here topology also. So basically what happens in the hub and kind of spoke topology, suppose this is our headquarter. Okay, it is our headquarter, and here we have the ISP and it is connected with two routers. Okay, they are the branches. Now what will happen, we don't want that this router, suppose this is router 2 and this is router 3, they should not form the neighborship. Okay, so how I'm gonna do that? We are gonna do that with the help of the static routing. Okay, so what we are gonna do here, suppose this is a router. Okay, in the here we will take switch. Okay, and here we are gonna take this router and this router. Now what I'm gonna do, okay, I will tell this router 1 that your neighbor is this and your neighbor is this. Okay, and this router 2 and router 3 also. Okay, we'll define them the neighbors. Now what will happen, they will form or they will update with the help of unicast hello message. When they will send in the unicast form, then these routers will not accept that hello message, because we have the, suppose here we are running 12.1.1.1 and here we are running 12.1.1.3. So basically, if a hello message is generated for 12.1.1.1, then that router will accept that hello message, not this router. This router will discard that packet, because for the first time it is switching up, so it will broadcast it. Okay, so let me show you that in the practical also. Okay, let us close this thing. Let me open router 3, router 4, and router 5. So let me capture this. Okay, let us close this thing. Okay, let us capture this E0/0. Okay, now what we are gonna do here, let us open router 3. Enable config will take this time IP address as IP address 192.168. Let us take 101.1 255.255.255.0. No shut, exit, router EIGRP 100. Will define the neighbor 192.168.101.2 and the exit interfaces E0/0. And let us make one loopback address also, and loopback one IP address, suppose 8.8.8 255.255.255.0. No shut, exit, will advertise both the prefixes network 8.8.8.8 0.0.255, and we will advertise that 192.168.101.0.0.255. So what will happen here, it hasn't generated any routers. Okay, because we haven't configured EIGRP on others router as right now. So let us do one thing, let us give the IP address. Okay, this is router 5. Let us open router 4 first. So here we will go into the router 4, enable config int E0/0 IP address 192.168.101.2 255.255.0. No shut, exit, router EIGRP 100. We will define the neighbor. The neighbor is 192.168.101.1 and the exit interface is E0/0. Okay, and we will define the network also 192.168.101.1. Let us say 0.0.255. Exit, router EIGRP. Okay, so it has formed the neighborship. Okay, हम यहाँ पे देख सकते हैं, we can see here that it has formed the neighborship. Okay, and both of them have generated the unicast destination address. Okay, so now what I'm gonna do, I'm gonna create on the router 5 as well int E0/0 IP address 192.168.101.3 255.255.255.255.0. Okay, let us do no shut here, exit, router EIGRP 100 network. Let us provide the neighbor here 192.168.101. क्या है 1 है ना. Okay, So, and we'll provide the interface, and here we will go into the network, and here we will advertise 101.0.0.255. So basically what is happening here, let us see that it should also form the neighborship. Neighborship अपनी आई है. अरे sorry, we'll go into the router EIGRP, and here we will type no, and in the network 192.168.101.3, let us write 255. Okay, let us see what is happening. Do show IP EIGRP neighbors. So it has formed the neighborship with 101.2. Do show. Let us see the IP address. Do show IP in VR router EIGRP. Do show IP protocol. Let us check that protocol is enabled or not. So protocol is enabled right now. So do show IP EIGRP topology. So here we have 101 dot, which is directly connected to the E0/0 interface. Let us configure again. No router EIGRP 100. Okay, let us again do router EIGRP 100. Network command 192.168.101.0.0.255. सो ये भेजना तो चालू कर देना चाहिए. अच्छा, नेबर 192.168.101.1 250, sorry, not 255, E0/0. Just a second. Okay, so here on the R3 we haven't told R3 that our neighbor is NEIG 192.168.101.3. Okay, E0/0. Now it should form. Okay, so it has formed the neighborship. Okay, so basically what was happening, that this is our topology. We have defined, we have told router 3, okay, that your neighbor is statically, basically I'm talking about statically, that your neighbor is, this is 192.168.101.2, but we haven't told R3 that your neighbor is 101.101.3. So that's why it was not forming the neighborship. We have, although we have told R5, okay, but we haven't told R3, so that's why it was not making the neighborship. Now it has formed the neighborship, as we can see here. Let me close this thing. Okay, as we can see here, it has formed the neighborship. Okay, यहाँ पे ऊपर. Okay, so here we can see 101.3, 101.1. So here we can see basically earlier what was happening, that when we were forming the neighborship, okay, like dynamically, so what was happening, that R1 was making this, sorry, this is R3. R3 was making neighborship with R4 and R5. Right now it is same, okay, because R3 we have taken as our headquarter, so it should form the neighborship with R4 and R5, but we don't want that our branches should form the neighborship with each other. Okay, so what was happening in the dynamic routing, that R4 was making neighborship with the R3 and R5 also. but we don't want that R4 should make the neighborship with the R5. That's why we have done it statically, so that now in the R4's neighbor table we can see that it has formed the neighborship with only let me show to show IP EIGRP neighbors. So it has formed the neighborship with E0/1 only. Okay, now let me open R5 exit to show IP EIGRP neighbor. So here also we can see that it has formed the neighborship with R3 only. Now let us open R3. Okay, in R3, how many tables we can see? Neighbors. So here we can see it has formed the neighborship with the 101.3 R3, I think R4 or R5. It has formed the neighborship with the R4 and R5 both. Okay. Now what happens that R1 can communicate, or we can say R3 can communicate with R4 and R5, but R4 and R5 cannot communicate with each other. Let me show you right now. Let me ping 192.168.101.4 है क्या है? Let us see the IP address to show IP in PR 101.3. So here we can see R4 is able to communicate with R5. Okay, so we don't want that R4 should communicate with R5 right now. Okay, there are two scenarios. Either we want our branches to communicate with each other, or we don't want our branches to communicate with each other. Okay, so now let us see R4 and R5. Do ping 192.168.101.2, I think. Yes. So they are able to communicate. Do show IP route. It has network of 101. Okay. Now what happens? Look here now. Instead of ISP, we are taking this switch. Okay, that's why it is able to communicate. But what we can do, we can stop this communication. Okay, according to the requirement of the clients. Okay, so just give me 2 minutes. Okay, so when you will try to communicate, okay, this R4 with R5 na on real devices, so basically they will not communicate. Okay, why they will not communicate? Because of the one method called, we call that method as split horizon. Okay, so what is that method? Okay, we will discuss that thing. Okay, so basically split horizon is basically enabled basically on the all the ports of this routers. Okay, so the reason that here we can see the communication because of the switches here. Okay, and this is the virtual images. Okay, so that's why maybe split horizon is not working properly here on these images. Basically what we can do, we can change the image, then we can see that. So basically let me tell you what the split horizon is. So suppose there are, okay, here we have the routers. Okay, suppose when R1 will send update now, it will not send directly connect on the directly connected interface, which is our E0/1. Okay, with R2 information. What I am telling, let me show you. Okay, suppose this is our R1. Okay, and it has one loopback address 10.1.1.0/24. Okay, which is directly connected to some E0/0 interface. Okay, and this is R2, and it has one LAN network. We call that 20 dot, let us suppose LAN network or loopback address, whatever we can say, and it is connected with also E0/0 interface. Okay, and here we have the IP 12.1.1.1 and 12.1.1.2. So basically in R1's routing table, how we can see that in R1's routing table, we can see the information as 10.1.1.0/24, which is directly connected to the E0/0 interface, and 12.1.1.0/24, which is directly connected to the E0/1 interface. Same goes for the here are 12.1.1.0/24, which is E0/0, and 20.1.1.1.0/24, which is E0, 12 वाला E0/1 है, and here E0/0. Okay, so what will happen here, that R1 will send an update. Okay, it will not send directly towards the directly connected interface. Okay, here towards directly connected interface with R2 information. Okay, it will only share the info of 10.1.1.0. Okay, so basically what I am telling you here, so whenever this R1 will send the message na, okay, it will send the information of only this network. We can say that a loopback, or we can say that as a LAN network. Okay, it will never share the information of its directly connected interfaces. Here we can see 12 prefix is directly connected now, so they are basically does not send addresses which are directly connected. It will only share the addresses which have like of loopback or the LAN networks, or we can say LAN prefixes. Okay, so basically let us define split horizon also. Basically what happens in split horizon, if prefixes advertise with same network, if prefixes advertise with same interface, then it will not advertise that prefix on that interface in update message. So what is the meaning of this? Suppose there's R4's information we have here, it got received from here. Okay, so it will not, when this R3 will update this info to R5 now, it in its update message we cannot see the information of, suppose here we are using 12.1.1.3's network, so it will not share the 12.1.1.0's network information towards R5 because of the split horizon mechanism. So because of this mechanism, it doesn't send the uh, that particular prefix information which are directly connected. Okay, or we can say if it will receive some particular prefix information from this particular interface, then it will not advertise that particular interface info on that particular, or we can say from that particular link. Okay, so that is the mechanism of the split horizon. So after this, okay, before moving ahead, let me show you the commands of the split horizon also. Okay, it is basically simple. We'll go into the any interface. Okay, if we want to enable it, we will write IP split horizon. Okay, and the protocol which we are running EIGRP, and the AS number, we are using AS number. If you want to disable that split horizon feature, we will know IP split horizon EIGRP 100. Okay, we have disabled it, and let me disable it on all the other routers also. And E0/0 IP split horizon EIGRP 100. Let us disable on the R5 also. And E0/0 IP split horizon EIGRP 100. So let us exit, do show IP EIGRP neighbors. So it has found the neighborship, it has already found the neighborship. Now let us try to ping 192.168.101.2. Okay. grouping 192.168.101.1. Okay, so they are pinging. Now there is one more concept. Okay, we'll, we'll discuss it. Like it is a next hope rule. Okay, which is in the EIGRP. So basically, what is next hope rule? Okay, first understand this next hope rule. Okay, so there is one more thing called next hope rule in EIGRP. So what this next hope rule is? So basically, let us suppose we have three routers: router one, router two, and router three. So they are connected with each other. Okay, and same here we can see. Suppose here we have the tens network 10.1.1.0/24. Suppose it is directly connected to E0/0, and here we are running 12.1.1.1, and here we are running 12.1.1.2, and here let us suppose we are running 23.1.1.2 and 23.1.1.3. Okay, so what happens that by default this IP next hop self is by default enabled on all the switches. It is by default enabled on all the interfaces. So basically in routers one routing table we can see the info like this: 10.1.0/24, which is directly connected to the E0/0 interface. Okay, and when this router once this loopbacks information, we can say when this router one is transferring, or we can say forwarding this information towards R2, then how it will forward? Okay, in router 2 how it will store? It will store like this: something 10.1.1.0/24 via, we say R1, but in reality it will show like this 12.1.1.1, because it will receive like this 12.1.1.1. Okay, and in the R3 it will be 23.1.1.2. Okay, so basically here in the R3, let us write down also, this is for R2, and for R3 this tens prefix will be stored like this via 23.1.1.2. Okay, now what does basically signify that suppose we have three routers: router 1, this is our switch, this is our router 2, and this is our router 3. So basically in IP root, before using this next hop self command, we'll use it after also. Okay, now okay, so we were talking about the split next hop rule in the AIGRP. So basically, what was happening that so what was happening that suppose we have created one loopback here. Okay, one loopback was created here 10.1.1.0. We can say 1. Here we have created one more loopback, which is 20.1.1.1.1, and here we have created one loopback 30.1.1.1. So basically they were this network is able to communicate because we have switch here. Okay, now when we will create one loopback here now, they will not able to communicate if split horizon feature is enabled. What this split horizon feature is, basically it is a loop avoidance mechanism. Okay, we will see in the practical also, okay, later, but And what was the next hop IP self is that we saw that on the R1, R2, R3, okay, R1 was showing that if there is some prefix information, suppose 10.1.1.0/24, okay, here in the R1 in its routing table, it will store in the which is with the help of like which for which interface it is directly connected. Okay, in the R2, it will write the next hop IP self, okay, which is the suppose 12.1.1.1 via 12.1.1.1, and here in the R3, it will store with the help of suppose here we are using 23.1. So via 23.1, I am storing the network of 10.1.1.0. So suppose if R3 wants to communicate with this, so what it will do? It will see that I want to communicate with 10.1.1.0. It will look into its routing table. It will see that I have to go with the this next hop address which is 23.1.1. It will transfer it to this router 2, and router 2 will see that 10.1.1.1 network is stored in my 23.1.1.1. Oh sorry, 12.1.1. I got this prefix information from 12.1.1.1. So I will send it to the 12.1.1, and now router 1 will see that where I have this information, it will see that I have this information on this E0/0 interface, so it will transfer that packet information towards that information. So this was the IP next hop self. Okay. Now what will happen? Suppose this 20.1.1.1 wants to communicate. Suppose this 20.1.1 is the LAN user, okay, of this branches, and this 30.1.1 is the branch of this. Okay. So if split horizon feature is enabled, then they will not able to communicate. Let me show you. Okay. So if split horizon feature is enabled, enable quantity. Okay, so this is R1. Let us open R4, enable quantity, and let us create one loop back here 20.1.1.IP address 20.1.1.1 255.255.255.0 no shut exit router EIGRP 100. Let us advertise this network also 0.0.255 exit. Now open R5, enable quantity router EIGRP. Okay, first let us create one loopback. Print loopback IP address 30.1.1.1 255.255.255.0 no shut exit router EIGRP 100 network enable 30.1.1 0.0.255 exit. So हमने split horizon feature enable करा था. Let us try to ping. Do ping 20.1.1. Okay, so they are able to communicate. Now let us do one thing on the R3 IP split. Let us go into the interface in T0/0 IP split horizon EIGRP 100. Now go into the T0/0. Here also let us enable split horizon IP split horizon EIGRP 100. And here let us also go to the T0/0 IP split horizon EIGRP 100 exit. So let us try to pin. So now we can see that if we have enabled split horizon mechanism on the interfaces, although by default it was enabled, okay, so its LAN user will not able to communicate. So if we want that we want our branches to communicate with each other, our branches LAN network should communicate with each other, so we have to disable that feature. Okay, so let us disable that feature. Okay, just write no here and no here. go to this and now here. Okay, so now they will able to communicate. Now if I will try to ping 30.1.1.1, so they will able to communicate. Okay, but how this 30's network is going? Okay, let me show you. Exit router. Let me show you first the routing table to show IP route. So it has 30's network information via 101.1. Okay, which is our the headquarter office. Okay, but we don't want our headquarter of office information should come here. Okay, it is coming because of this IP next hop self. Okay, so what we can do, we can disable this feature. Okay, so how we can disable this feature? Let me show you on the trace route also. Like if I will try to, this is our router 4 now. 30.1.1.1. So we can see here it is going from the router 1 or router 3, whatever our way from whatever we have given. Okay, then it is going towards R3. Now what I'm gonna do, okay, this 101 is for the router 3. Okay, don't get confused. Now what I'm gonna do, I'm gonna exit. Okay, and I will show you that if I will write no IP interface C0/0 no IP next hop self EIGRP 100. Okay, now if I will try to trace route, so now we can see here that it is going directly towards our now it is going directly towards R5. Okay, so earlier with the help of IP next hop self it was going like this. Okay, we can see the IP address of this also, but now we can see that it is going directly. Okay, so that's it for today.